In this video, we're gonna prove this formula z0 root z1 open bracket z1 plus 2z2. This formula is for characteristic impedance. Now, to solve this kind of question, or to get back to this equation, we have to draw the circuit diagram in order to understand this. So the circuit diagram looks like this. Now we are looking for Z0. Don't forget this, we are solving this by using the same rules for finding R equivalent in a circuit. Now let's say this one is Z1, this one also is Z1, this one is Z2, this one is Z0. So Z1 equal to each series arm. Now Z2 equal to each shunt arm. Then Z0 equal to that characteristic impedance. Now, when you have something like this, let's solve this. You have Z1 and Z1, Z2, Z0. You know, this is in series with this. So we have Z1 and Z0. And in a series circuit, we say the resistors, they are additive. We just use resistor as an example in order to get the equation to solve this problem. Now say, let's redraw the circuit. We will be redrawing some circuit, so for better understanding, you say this now this has become 1. Don't forget Z1 and Z0. Now, since they are just they are not a value, or they are not a digit that we can add it together, so it will just be like Z1 plus Z0. See this? Z1 plus Z0. That is this and this. Now they are now in parallel to Z2. Now let's solve this first. When this one and this one, they are in parallel, you know, it will be like, the circuit will now be like this. So, you know, since they are in parallel, it will now be Z2 multiplied by Z1 plus Z0 over Z2 plus Z1 plus Z0. No, now this one has become 1. Also, they are now in series with Z1. Now we are finding solution to our problem small. So now we now have Z0 or Z equivalent, so equal to Z1 plus, you know, they are in series, so you are adding all of this to this. So Z1 plus Z2 open bracket Z1 plus Z0 close bracket over Z2 plus Z1 plus Z0. As you can see this, now we said don't forget that any whole number is over 1. So now let's find the LCM of this. So we are using this equation to prove this formula. We said earlier Z0 equal to Z1 open bracket Z1 plus 2Z2. That is characteristic impedance. So we are using this one that we've obtained by this circuit. Now, what else? Let's find the LCM. You know, we said for any whole number is over 1. Let's say over 1. Now this and this. So this one multiplied by this, it will give us this. Definitely we are going to use this denominator as the LCM. Now Z2 plus Z1 plus Z0. Now 1 in all this, it will give us all this back. So we are having Z1 open bracket Z2 plus Z1 plus Z0 close bracket. Then plus this in this will give us 1. So 1 times the numerator, it will give us Z2 open bracket Z1 plus Z0 all over Z2 plus Z1 plus Z0. Now Z0 equal to this. What's the next step? The next step is that we are to cross multiply. Cross multiply. So when we are crossing multiply, this one goes this way and this way. Don't forget, any whole number is over 1. Don't forget that any whole number is over 1. So this one comes here. So Z0 open bracket Z2 plus Z1 plus Z0 equal to Z1 open bracket Z2 plus Z1 plus Z0 close bracket plus Z2 open bracket Z1 plus Z0. Now let's expand, or let's open the bracket. Open the brackets. Open the brackets. Now let's first open the one at the left hand side. So Z0 times Z2 plus Z0 times Z1 will be Z0 Z1. Z0 times Z0 will now be plus Z0 square equal to this. To the right hand side, Z1 times Z2 to now be Z1 Z2 plus Z1 square. This times this will give us Z1 square plus Z0 Z1 plus Z1 Z2 plus Z0 Z2. Don't mind me, you can see this one very well. This one is Z0 Z2. Don't forget. Now what are we going to do? We are going to collect like terms. Collect like terms. Collect like terms. Now when we are collecting the like terms, don't forget we are looking for the Z0. Now we now say let's use this one. Z0 square equal to, we are taking all this and this to the right hand side. So we have something like this: Z1 Z2 plus Z1 square plus Z0 Z1 plus Z1 Z2 plus Z0, you know this one is Z0 Z2. You know, when you take this one to this side, it will come negative, that is minus. Now we now have minus Z0 Z2 minus Z0 Z1. So we have, let's check for this. We have Z0 Z1 minus Z0 Z2. So let's look. Okay, we have Z0 Z2 and we have minus Z0 Z2. So this one, when you subtract this one from this one, it will give us 0. So let's cancel this. Now we have Z0 Z1 minus. Let's look. Do we have any Z0 Z1? Yes, we have. So this one cross this one out. So the remaining one will now be Z0 square equal to Z1 Z2 plus Z1 square plus Z1 Z2. Now, when we rearrange this, let's rearrange this for better understanding so it can be clear to us very well. This one and this one is like we are collecting like times. So z1, z2, z1, z2. Let's mark them together. So we have z naught equal to z naught square. Sorry, z naught square equal to z1, z2 plus z1, z2 plus z1 square. So it's still the same thing. When we rearrange this, we have z naught square equal to z1 square. This and this, they are the same thing. So when we add it together, it will now be plus 2z1 z2. So now let's factorize this right hand side. Factorize. When we factorize this, we obtain something like this. Z1, you see, Z1 open bracket, Z1 again. So when you multiply this and this, it will give us this back. Z1 open bracket, Z1 plus 2z2. You may be wondering how we got this. Now we can take this one back to this. Z1 times Z1 give us Z1 square. Then Z1 times 2z2, it will give us 2z1 z2. Now what are we going to do? We are going to square the both sides. Square the both sides. When we square the both sides, so it will now be z naught square equal to z1 open bracket z1 plus 2z2. This root, we cancel this. This cancel this. It should now be z naught equal to root z1 open bracket z1 plus 2z2. So now this is what we've been looking for. This is the answer we've been looking for. So we've proved this. It says z naught equal to root z1 open bracket z1 plus 2z2. So it's the same thing as the first question we are to prove. We have z naught equal to root z1 open bracket z1 plus 2z2. So this is the formula for the characteristic impedance. Thank you. If you have any question or any explanation on this video, there is link in the description of this video, so you can check and you can contact us. Thank you. Please like and subscribe to our YouTube channel. Thank you.